solve between 360 and 540 degrees, this equation that we have here. So this is an equation that we can turn into a quadratic, and we can turn it into a quadratic by using this identity, using sine squared x plus cos squared x is equal to 1. Rearrange this for sine squared x, and we get this. And then we sub that into what we have here, so it becomes the sine squared x becomes 1 minus cos squared x. And then we can expand out the brackets. So the 12 and the minus 13 become minus 1. And I'm just going to times everything by minus 1 just because it's nice, I guess. Okay, so we have a quadratic. So if I were to say, let y equals cos x, this equation becomes 12y squared minus 7y plus 1 is 0. So there is your quadratic. When we solve this quadratic, we end up with y is equal to a third and y is equal to a quarter. And remember that y is equal to cos x, so this is the same thing as cos x is a third and cos x is a quarter. So we're trying to solve between 360 and 540. Okay, so let's first do inverse cos of these two values. So for the first one, inverse cos of 1 over 3, that gives us 70.5 degrees. And for a quarter, we end up with 75.5. So I'm going to work out the values between 0 and 360. And then, because we know a cos graph repeats itself every 360 degrees, then we can just add 360 to our values that we work out between 0 and 360 to get the solutions in this interval. So 70.5 is here somewhere. So using the symmetry of the graph, we know that 70.5 is 70.5 away from 0, and therefore it must be 70.5 away from 360. This here is 360. So this angle here would therefore be 360 minus 70.5, which is 289.5. And then we can add 360 to both of these angles, and we end up with 430.5 and 649.5. So we see from what we have here, the only angle in this domain is this one. Okay, now we do the same thing for the 75.5, so we can do the same thing where we take away 75.5 from 360, which gives us 284.5, and then add 360 to both. We get 435.5 and 644.5, and again we see that this is the only value in this domain, so those are our two answers. 430.5 and 435.5. Says to one decimal place, which is what we have for our final solutions.